given that a matrix A is 5, 2, 1, 0, negative 1, negative 1, 10, 3, 0, determine A inverse using the cofactor method. So here we are finding the inverse of our matrix, which is 3 by 3 matrix, and we are using the cofactor method. So first of all, let us have the steps that are followed when you are calculating inverse of a matrix using the cofactor method. So step 1, you have to calculate what we call matrix of minus. Step 2, after that, you turn the result in step 1, you turn it into what we call matrix of cofactors. Matrix of cofactors. After that, in step 3, what you got in step 2, you change it to what we call the adjugate. Adjugate just means transposing. You transpose the matrix in step 2. Then the last step, you multiply the result in step 3 with 1 over determinant. You multiply with 1 over determinant. So we are going to use these 4 steps to calculate our inverse. So let us start. First of all, now we calculate what we call the matrix of minus. So to get matrix of minus, what you do, you have to write the matrices, the minor matrices for each element. The minor matrix is when, for example, for element 5, you have to ignore the column in which 5 is and also the row. So if you ignore this column and this row, you remain with this matrix. So that is the minor for 5. So you write it. So it is negative 1, negative 1, 3, 0. So you write all minor matrices for all elements. For 2, you ignore this column and this row. So you will remain with 0, negative 1, 10, 0. So we have 0, negative 1, 10, 0. You go for 1, you ignore this and this, you remain with this. So we write that we have 0, negative 1, 10, 3. You follow the same steps for element 0, negative 1, negative 1, 10, 3, 0. Ignoring the row in which the element is and the column. So for this 0 in our middle row, for the first 0 here, it will be 2, 1, 3, 0. We move to negative 1, which will be 5, 1, 5, 1, 10, 3. We have this is -1, we have to ignore this column and this row. Yes, so it will be 5 1 10 0. Then we have 5 2 10 3. We write for the last row 2 1 -1 -1. We have 5 1 0 -1. Then 5 2 0 -1. So after writing those small matrices, now we have 2 by 2 matrices for each element. So these are minor matrices for every element. So to get the matrix of minus, which is step 1, you calculate the determinant for each of the matrices to get a single element in each position where the matrices are. So for 2 by 2 matrix, determinant is given by principal diagonal, which is a product, minus the product of the other diagonal. So for the first matrix, we get 0 multiplied by -1 minus 3 times -1. And we write the result. So let's have it here. So for the first matrix, this one, determinant is 3. The second matrix which follows, we have 10, we have 10, we have -3, we have -10, we have -5, we have -1, -5, -5. So what we are doing is just getting the determinant of each of these matrices, product of main diagonal minus product of the other diagonal. We have this. So this is what we call matrix of minus. So that is step 1. Let's go to step 2. We are changing this matrix into what we call matrix of cofactors. So step 2, we change to matrix of cofactors. To do this, you apply our matrix that we got in step 1 to what we call the checkboard. We apply it to a checkboard of minuses. So our matrix was 3 10 10 -3 -10 -5. We had -1 -5 -5. So what you do for this matrix to change it to a matrix of cofactors, you write another matrix of signs alternating plus sign and minus sign, and you write a matrix of those signs which is of the same order of like this matrix. So in this case, you have to start with the plus sign. So we have plus minus plus minus plus minus plus minus plus. You have to write it, but you have to start with the plus sign. Then you alternate plus minus to get a matrix of same size as this one. So we will be multiplying the element in each respective position with the sign. So when you do that, the first element is 3 positive. We multiply with our first positive here, we shall get 3. The second one is positive 10. We multiply with negative, we get negative 10. We get 10. The next one is negative 3. We multiply with the negative. Negative and negative gives us positive. So we shall have 3. Then next we get negative 10 remains. Next will be 5. Next we get negative 1. 5, negative 1, negative 5. So step 2 is over, which is matrix of cofactors. So this is the matrix of cofactors. We go to step number 3, which is changing it to an adjugate. Adjugate, you just transpose our matrix of cofactors. So in this case, to transpose a matrix, you have to change the rows into columns and columns into rows. So the first row forms our first column. So we shall have 3, negative 10, 10, 3, negative 10, 5, negative 1, 5, negative 5. So that is our step number 3, which is the adjugate or the matrix of cofactors being transposed. Now, in step 4, we said you have to multiply what we got in step 3 with 1 over determinant. So we have now to calculate the determinant for our matrix. And in this case, you have to note that this is the determinant of our original matrix, not determinant of our matrix in step 3. So we shall calculate determinant of our original matrix, this one. So our original matrix was 5, 2, 1, 0, negative 1, negative 1, 10, 3, 0. So generally, let me show you. Generally, when we have a 3 by 3 matrix, let's say we have a 3 by 3 matrix of elements A, B, C, D, E, F, G, H, I, and we want to find the determinant of this matrix. What we normally do is you consider the first row. You consider the first row only. Then in each element in first row, you take the value multiplied by the determinant of its minor. Minor is the matrix when you ignore the current column and row. That is, in this case, we are getting the determinant for this 3 by 3 matrix as our A. When using the general matrix, A, we ignore this column and this row. So first we take A, we multiply with determinant of the minor of A is E, F, G, I. It is E, F, H, I. So it is EFHI. Then we follow with minus. That is something else you have to note. Then we take B multiplied by determinant of its minor, which is, we ignore this column and this row, we shall have DFGI. So we have DFGI. Then we add C multiplied by determinant of its minor, which is DEGH. So you have to note this minus and this plus. It is a must that they follow one another in that order. So we shall apply this formula in this matrix to get our determinant. So let's proceed. So let me repeat our matrix, which is 5, 2, 1, 0, -1, -1, 10, 3, 0. So we apply our formula that we got in our previous step. So we shall have first row, which is 5. So we shall have our determinant being equal to 5. We multiply with determinant of the minor for 5. We ignore the current column and row. We shall have -1, -1, 3, 0. We subtract 2 times the determinant of its minor, which is 0, -1, 10, 0. This is 10. This is 10. Then we add 1 multiplied by the determinant of the matrix, 0, -1, 10, 3. Yes. So this will be equal to, so you have to find the determinant of each of these matrices. So we shall have, when you find that, we shall get 5 times 3 minus 2, 2 multiplied by 10, plus 1 multiplied by 10. And this will give us 15 minus 20 plus 10. And our determinant will be 25 minus 20, which is 5. So the determinant of our matrix is 5. So we take 1 over 5, we multiply with our matrix, which is the adjugate, which is this matrix. So we multiply 1 over 5 times this matrix. So we have we have 1 over 5 times 3, -1, -10, -10, 5, 10, 5, -5. which is our matrix, this one. So 1 over 5 is a scalar, so we multiply it with every element in the matrix. So we shall have 3 over 5, 3 over 5, negative 1 over 5, negative 10 over 5, negative 10 over 5, 5 over 5, negative 10, is 10 not negative, this is 10 positive, this should be 10 over 5, then 5 over 5, and then negative 5 over 5. So we have that matrix. Let's compute and have 3 over 5 is 0 0.6, 0 0.6, negative 0 0.2, we have negative 2, negative 2, 1, we have 2, we have 1, then we have negative 1. So we have multiplied with 1 over determinant. So that one gives us our final answer, which is the inverse of A. So you have to follow all those steps in order to get the inverse of a 3 by 3 matrix using the cofactor method.